At first, it looked like nothing more than a routine freight train moving through the night on schedule, protected, untouchable. No explosions, no alarms, no warning signs. Then the footage emerged. What followed wasn't a battle, a sabotage, or a lucky strike, but something far more unsettling. A perfectly timed operation that turned momentum itself into a weapon. This wasn't supposed to be possible, and once you understand how it happened, you'll realize why no logistics system will ever feel truly safe again. The operation marked a quiet but profound shift in how logistics is attacked in modern warfare, not by focusing on physical infrastructure, but by weaponizing time itself. Traditionally, logistics interdiction has centered on destroying bridges, rail junctions, depots or roads, fixed objects whose absence is meant to halt movement. In this case, Ukraine ignored the infrastructure entirely and focused instead on the moment when movement became irreversible. Once the train entered a corridor with no viable bypass routes, no sidings capable of holding its mass, and no gradients that allowed emergency reversal, it was no longer a vehicle in transit. It was a system locked into motion. From that point forward, every kilometer reduced options rather than expanding them. The decisive vulnerability was not steel or concrete, but commitment. By allowing the train to proceed unchallenged, Ukrainian planners transformed inevitability into a weapon. The train could not stop without catastrophic risk, could not reverse under its own load, and could not reroute without dismantling the schedule of an entire logistics network. Time replaced geography as the kill zone. The attack was therefore not about where to strike, but about when the outcome could no longer be altered. Once the train crossed, that invisible threshold, destruction became optional rather than necessary. The result was already predetermined. This represents a shift from spatial interdiction, denying access to a place, to temporal entrapment, denying the enemy the ability to change decisions after a certain moment has passed. This approach also minimized escalation and resource expenditure. Destroying a bridge would have been loud, politically visible, and repairable. Attacking layered air defenses head-on would have invited attrition. Instead, Ukraine waited for a point in time when intervention required minimal force, but delivered maximal consequence. The train's momentum, once a symbol of efficiency and planning, became its greatest weakness. In modern conflict, logistics no longer fails when routes are broken. It fails when timing collapses. Control over time, over when choices disappear, has become as decisive as control over territory and far harder to defend against. What made this operation possible was not a dramatic intelligence breakthrough, but the quiet exploitation of a detail most observers would dismiss as routine noise axle load data. A freight train running 42% above its rated axle capacity is not just a technical anomaly, it is a behavioral signal. Civilian rail operators avoid such margins because they accelerate wear, invite derailments, and attract regulatory scrutiny. Choosing to ignore those constraints reveals something deeper than cargo weight. It reveals intent and urgency. In this case, the overload indicated that speed had been prioritized over safety, suggesting a delivery timeline that could not slip without operational consequences at the front. Ukraine did not need to see inside the rail cars to understand what mattered. The numbers alone told a story of pressure, haste, and strategic dependence. This marks an evolution in how intelligence is extracted from civilian infrastructure. Rather than treating rail networks as neutral background systems, Ukrainian analysts treated them as living datasets that reflect decision-making under stress. Axle load, schedule consistency, braking profiles, and thermal output together form a behavioral fingerprint. When those metrics drift outside civilian norms, they reveal not just what is moving, but why it must move now. This approach shifts intelligence gathering away from traditional questions of location and toward inference of intent. The train became identifiable as military cargo not because it was hidden poorly, but because it was moving in a way that civilian logic would never justify. Some will see this as a risky analytical leap, arguing that anomalies alone should never justify a kinetic strike. Others may counter that. In a contested environment where camouflage is the norm, intent-based signals are the only reliable indicators left. The more civilian systems are militarized, the more their data betrays the pressures behind them. What is striking is how inexpensive and deniable this form of intelligence is. No infiltration, no sabotage, no exposure, just patient observation of systems behaving under strain. Whether this represents a dangerous precedent or a necessary adaptation is open to debate. As warfare increasingly hides behind civilian infrastructure, the line between routine data and strategic signal continues to blur. I'm curious how you see it. Does this kind of inference cross a line? Or does it simply reflect the realities of modern conflict? Share your thoughts in the comments. What ultimately exposed the true nature of the cargo was not a glimpse inside the rail cars, nor a leaked manifest, but something far more subtle and far harder to falsify: thermal consistency. Humanitarian or civilian freight behaves thermally in irregular ways. Refrigerated goods, cycle machinery, cools, between use and mechanical systems, produce uneven heat signatures tied to operation and friction. What Ukrainian analysts observed instead was a sustained uniform thermal output temperatures, remaining elevated hour after hour without fluctuation, fault spikes, or cooling intervals. That pattern alone ruled out benign explanations. Heat that does not breathe, does not pulse, and does not decay points to one thing: dense, energy-rich materials designed to remain stable under transport, such as artillery shells and solid rocket propellant. This marked a shift in how intelligence was derived. Visual confirmation, long the gold standard of reconnaissance, was no longer necessary. Ukraine did not need to identify specific munitions or count crates. The question was no longer what is inside the train, but what kind of cargo could physically sustain this thermal profile over time. That is a fundamentally different analytical lens. It treats heat not as a byproduct to be filtered out, but as the primary signal. In doing so, it turns camouflage into a liability, because hiding objects does nothing to hide the physics governing them. The absence of thermal anomalies was as revealing as their presence. There were no indications of onboard fires, no erratic hotspots caused by failing components, no cooling cycles that would suggest climate-controlled civilian goods. Instead, the heat was dense, continuous, and internally distributed, exactly what would be expected from tightly packed energetic materials, absorbing and retaining ambient and mechanical warmth. This kind of consistency cannot be improvised without fundamentally altering the cargo itself, making it extremely difficult to spoof convincingly. More importantly, this approach reflects a maturation in ISR logic, from identification to elimination by exclusion. Ukraine did not prove the cargo was military by naming it. It proved it by ruling out everything it could not be. Thermal behavior became a form of truth serum, revealing intent through physical law rather than human declaration. In a battlefield increasingly saturated with deception, this method shows how modern intelligence is moving away from appearances and toward invariance, signals that cannot lie because they obey the same rules everywhere. What made the train vulnerable was not its visibility, its cargo, or even the defenses surrounding it, but the moment it surrendered flexibility to the geometry of the rail network. Rail systems promise efficiency through fixed routes, predictable gradients, and tightly scheduled movement. In this operation, that promise became a constraint. Once the train entered a corridor with no bypass tracks, no sidings capable of absorbing its mass, and no feasible points for reversal, the network itself closed around it. Every kilometer traveled reduced options rather than advancing safety. Ukraine did not need to block the corridor. It only needed to wait until the corridor blocked the train. This reflects a deeper understanding of infrastructure as a system of commitments rather than pathways. Roads allow improvisation. Sea routes allow dispersal. Railways demand obedience to topology. When that topology is fully mapped, continuously observed, and analytically modeled, it becomes a tool that can be exploited offensively. Ukraine weaponized inevitability. The train's schedule, weight, and route transformed it from a mobile asset into a predictable object whose future state could be calculated with high confidence. At that point, intervention became a matter of timing, not pursuit. Under persistent surveillance, rail superiority becomes paradoxical. The very features that make rail transport attractive, high-throughput fixed routes, centralized control, also make it uniquely vulnerable once adversaries achieve informational dominance. Flexibility disappears long before the train reaches its destination. What remains is momentum without agency. The train could not slow without risking. Derailment could not stop without blocking the line and could not divert without dismantling an entire logistics plan downstream. Infrastructure that was designed to guarantee movement instead guaranteed exposure. This reframing has broader implications. Military planners have long treated rail networks as protected arteries, assuming that defense redundancy and rapid repair would preserve their utility. This operation suggests a different reality. Once a system crosses a point of commitment, it no longer needs to be destroyed to be defeated. It only needs to be observed until it traps itself. In that sense, the attack was not against the train or the track, but against choice itself. Mobility did not fail because it was interrupted. It failed because it became compulsory. The air defense phase of the operation was not a failed attempt to break through layered protection, but a deliberate exercise in strategic exhaustion. The decoy UAVs were never expected to survive, and they were never intended to open a permanent corridor through defended airspace. Their purpose was to consume attention, time, and resources at a rate that favored the attacker. By presenting highly visible, deliberately provocative targets, Ukraine forced Russian air defense crews to respond exactly as they were trained to do, quickly, decisively, and with expensive interceptors. From a tactical standpoint, the defenses performed well. Targets were detected, tracked, and destroyed. From a strategic standpoint, the system was being quietly hollowed out. Every interceptor launched represented a financial and logistical asymmetry. Missiles costing millions were expended against decoys worth a fraction of that, but the imbalance went beyond money. Reload cycles, crew fatigue, heat-stressed cannons, and shrinking missile inventories all accumulated simultaneously. As the engagement continued, operators became absorbed in the immediate success of intercepting airborne threats, while the system as a whole drifted towards saturation. This is where the logic inverted. Success at the tactical level produced failure at the operational one. The defenses were winning each exchange while losing the larger contest for readiness and awareness. The most damaging effect was not depletion of hardware, but depletion of cognition. High-tempo engagements narrow perception. Screens fill alarms, overlap, and decision-making compresses into instinctive reactions. In that environment, attention becomes a finite resource, and anything outside the dominant threat axis begins to disappear. Ukraine exploited this by ensuring the threat remained above, loud and persistent drawing, focus upward until everything else became secondary. Blindness emerged not from malfunction, but from overload. There is no single correct interpretation here. Some professionals might argue that the defenses did exactly what they were designed to do, and that expending munitions is preferable to risking a breakthrough. Others may see the episode as evidence that modern air defense can be defeated without being penetrated at all, simply by forcing it to perform continuously until it loses flexibility. What is clear is that this phase reframed air defense not as a shield to be pierced, but as a system to be exhausted. In that context, interception itself became the vulnerability, and success became the pathway to failure. One of the most subtle and decisive elements of the operation was not technological at all, but psychological. Modern air defense systems, no matter how advanced, are designed around a fundamental assumption: the most dangerous threat comes from above. Radars sweep upward. Operators are trained to prioritize aerial contacts, and automated systems allocate resources toward objects descending from altitude. Ukraine exploited this bias by deliberately pulling attention vertically, creating a momentary distortion in how the defensive picture was perceived. When sensors, weapons, and human focus tilted skyward in unison, the space below them became briefly irrelevant. That window lasted only seconds, but in modern warfare, seconds are decisive. This was not a failure of hardware. The systems worked as intended. The failure was one of orientation. By flooding upper airspace with visible noisy threats, Ukraine ensured that detection, tracking, and engagement cycles were consumed in a single vertical plane. Human operators leaned into the screens. Alarms cascaded, and automated prioritization routines locked onto the most immediate danger. In doing so, the defense effectively simplified the battlefield for itself, collapsing a three-dimensional problem into a two-dimensional one. Anything operating outside that plane benefited from neglect, not invisibility. The key insight here is that attention is both finite and directional. It cannot be evenly distributed across all domains at once, especially under stress. When threat density increases in one direction, awareness in others degrades automatically. Ukraine did not need to eliminate sensors or jam radars completely. It only needed to overload them long enough to redirect focus. The resulting blind zone was not permanent and not total, but it did not need to be. It existed just long enough for the real strike to pass through unnoticed. This approach points to a broader principle. In modern defense systems, optimized for detecting threats, may be most vulnerable when those threats are deliberately shaped to control perception rather than penetrate it. The operation demonstrated that winning does not always require being unseen. Sometimes it requires being seen too clearly in the wrong place. By dictating where defenders looked, Ukraine dictated where they did not. In a battle space where sensors are everywhere, control over attention may matter more than control over airspace. The moment defenses looked up together, the decisive action occurred below quietly and irreversibly. The final strike phase revealed a quiet but significant shift in how precision attacks are being designed under conditions of intense electronic warfare. Rather than relying on continuous communication links, Ukraine chose to remove the electromagnetic spectrum from the equation almost entirely. The strike drones operated with onboard targeting logic, preloaded parameters, and decision rules defined well before launch. Once released, they did not ask for guidance updates or permission. In an environment saturated with jamming, spoofing, and signal noise, this absence of dependency became their greatest strength. What could not be detected could not be disrupted, and what did not transmit could not be silenced. This approach reflects a growing recognition that the most contested space in modern warfare is no longer air or land, but the invisible layer of connectivity that ties sensors to shooters. Networked control offers flexibility, but it also creates exposure. Every radio emission is a signature, every data link a potential point of failure. By severing that link, in the terminal phase, Ukraine accepted reduced adaptability in exchange for survivability and certainty. The drones did not need to be retasked. They needed only to complete a single well-defined function under hostile conditions. The use of autonomous logic also altered the defender's calculus. Traditional electronic warfare aims to confuse, delay, or misdirect an adversary by corrupting information flows. Against a system that no longer depends on those flows, many of those tools lose relevance. Jamming becomes noise without effect, and spoofing has nothing to latch onto. The battlefield becomes simpler for the attacker and more opaque for the defender, reversing the usual advantage of sophisticated EW systems. More broadly, this signals a doctrinal shift away from real-time command toward pre-decision. Authority and intent are pushed forward in time, embedded into the weapon itself. The critical choices are made before launch, not during flight. This does not eliminate human control, it relocates it. Planning replaces improvisation, and design replaces reaction. In the terminal phase, autonomy is not about artificial intelligence making strategic decisions, but about resilience, ensuring that once an attack begins, it cannot be talked out of existence by interference. In a battle space where connectivity is fragile and contested, the ability to act without it may define effectiveness more than the ability to command through it. The decisive insight behind the strike was not where to hit the train, but what to ignite within it. Rather than aiming for locomotives, brakes, or couplings, the traditional targets used to stop movement, the attack focused on internal energy density. Thermal gradients across the train revealed which railcars contained the most volatile cargo, allowing the strike drones to prioritize lethality over disruption. The goal was not to halt the train, it was to transform it into its own weapon. By selecting the hottest cars, the drones ensured that each impact would trigger cascading reactions rather than isolated damage. This approach reflects a sophisticated understanding of logistics as a physical system governed by mass temperature and stored energy. A disabled locomotive can be replaced, a severed coupling can be repaired, but once tightly packed munitions and propellant ignite, the system ceases to exist in any recoverable form. Heat-seeking logic turned the train's payload against itself, collapsing the distinction between transport and detonation. The strike exploited the fact that energetic materials do not fail gracefully. They amplify damage through pressure heat and fragmentation, spreading destruction far beyond the point of impact. By targeting energy density instead of mobility, Ukraine bypassed the logic of delay and repair that usually governs interdiction. Even if the train had stopped immediately, the internal reactions would have continued escalating faster than any emergency response could contain. This rendered defensive measures irrelevant in the final moments. Guards could fire at drones, crews could attempt emergency braking, but none of that addressed the true threat once ignition began. The decisive factor was not control of movement, but control of physics. The broader implication is a shift in how logistics vulnerability is assessed. Traditional doctrine emphasizes choke points and bottlenecks, but this operation demonstrates that the most fragile element may be the cargo itself. When energy density is high enough, the container becomes incidental. Destroying movement delays logistics. Destroying energy eliminates it. The drones did not need to destroy every car. They needed only to find the right ones. In doing so, they revealed a principle that is likely to shape future strikes in complex systems. The fastest way to collapse the whole is not to attack its structure, but to trigger the forces it is designed to carry safely. What followed the strike was not a scene of wreckage to be cleared, but a stretch of rail that had been fundamentally altered at the material level. The extreme temperatures generated by the cascading detonations did more than bend steel or scatter debris. They changed the chemical and structural properties of the rail system itself. Rails lost their temper ballast, partially fused, and expansion joints failed in ways that could not be corrected with standard field repairs. This was no longer a matter of removing damaged cars and relaying track sections. The rail line ceased to function as a rail line because its underlying materials no longer behaved as engineered. This distinction is critical. Tactical rail damage is designed to be reversible. Crews expect craters, twisted metal, and broken sleepers, and they train to restore service quickly under fire. What happened here pushed the problem into an entirely different category. Prolonged exposure to temperatures exceeding 1,000 degrees altered the crystalline structure of the steel, reducing load tolerance and introducing unpredictable fracture risks. Ballast stones cracked, fused, and lost their drainage properties. Even sections that appeared visually intact could no longer be trusted to carry heavy loads at speed. Before trains could return, the line would require controlled cooling, metallurgical assessment, partial replacement, and reconstruction under hazardous conditions. By achieving denial through transformation rather than destruction, the strike extended its effects far beyond the moment of impact. The absence of a collapsed bridge or visible crater did not make recovery easier. It made it slower. Every repair decision carried uncertainty, and uncertainty in logistics translates directly into delay. The rail line became a liability, not an asset, until proven otherwise. That proof would take time measured in weeks or months, not hours. This approach reflects a sophisticated understanding of infrastructure warfare. Instead of repeatedly attacking the same node, Ukraine imposed a form of industrial-scale denial that resisted quick adaptation. The explosion ended quickly, but its consequences persisted because they were embedded in the materials themselves. If you value objective analysis over speculation and noise, consider following this channel. The focus here is not on spectacle, but on how decisions are made and how those decisions reshape outcomes long after the fire fades. The most consequential outcome of the strike was not the loss of rail cars, munitions, or even an entire supply train, but the destruction of momentum. Modern military operations are built around synchronized timing. Units plan not just on what they will receive, but when they will receive it, aligning fire missions, drone sorties, and maneuver phases to narrow windows of opportunity. That train was more than a delivery. It was a temporal anchor. Its arrival time structured multiple formations simultaneously. When it vanished, the plans attached to it unraveled in ways that could not be repaired by simple substitution. Ukraine did not merely slow Russian operations, it forced a strategic dilemma. Commanders were left with two options, neither of which preserved coherence. They could pause, allowing depleted units to conserve resources while awaiting replacement supplies at the cost of initiative and pressure. Or they could cannibalize reserves intended for later phases, sustaining short-term activity while hollowing out future operations. Both choices compound failure over time. A pause creates gaps that the adversary can exploit. Cannibalization creates fragile follow-on phases that collapse under stress. In either case, the rhythm of operations breaks. Momentum differs from materiel. In a crucial way, it cannot be stockpiled. Ammunition can be stored, vehicles can be repaired, troops can be rotated, Tempo exists only in motion sustained by uninterrupted flow. Once that flow is disrupted, rebuilding momentum requires more than replacing what was lost. It requires resynchronizing decisions across units that are now out of phase with one another. This is far more difficult than resupplying a single formation. The effects radiate outward quietly. Fire rates drop, sortie density thins, and commanders begin making decisions reactively rather than proactively. Each choice becomes smaller, more cautious, more constrained. The battlefield may look unchanged on a map, but the internal clock of the force has been knocked out of alignment. That is why the loss was strategic rather than tactical. The train's destruction did not announce itself with immediate collapse. It introduced hesitation, and in modern warfare, hesitation spreads faster than damage, eroding effectiveness day by day, until the initiative is no longer something that can be reclaimed, only remembered. When you step back from the battlefield details, the lesson here is surprisingly familiar to everyday life. Success rarely collapses because of one dramatic mistake. It erodes when timing is lost, when small signals are ignored, and when momentum quietly slips away. The train did not fail because it was weak. It failed because it became committed to a path without flexibility. Many people do the same, locking themselves into routines, assumptions, or plans that once felt safe until change becomes difficult and costly. This story also reminds us that what looks strong on the surface can still be fragile underneath. Expensive defenses, busy schedules, and constant activity can create the illusion of control while attention is being pulled in the wrong direction. Progress depends less on force and more on awareness, knowing when to act, when to pause, and when a small adjustment in timing can prevent a much larger loss later. Perhaps the most enduring lesson is this: momentum matters, but it cannot be stored for later. In work relationships, health, or personal goals, once rhythm is broken, restoring it takes far more effort than maintaining it. Paying attention to early signals, staying flexible, and protecting your sense of direction can make the difference between moving forward and slowly drifting off course. In the end, the most valuable thing lost that night was not material, it was certainty. And preserving that in any stage of life is often the real challenge.